No. You don't have to copy anything down. Just pay attention. I'll just talk about the proof is not for examination. I'll just talk about this. You don't have to copy anything down. If you want, you can copy this later, but you don't have to copy down what's on this page. Stop stressing. This is not examinable, but it is the introduction to the concept. Because for you to understand the concept, it's better for you to have some kind of foundation to it. You understand? Not just knowing the formula. Okay? So the compound angle formulae, they are actually a group of formulae that are used or that involve the ratio of trig ratios, like for example sine, cos. Okay, in this case, in your case, guys, you don't do 10. So they involve trigonometric ratio of the sum of two angles or difference of two angles. Like for example, you may need to know, let's say, what is sine A plus B. Okay, this can be simplified. Okay, or say cos A minus B. So we have got trigonometric ratios of the sum and trigonometric ratios of a difference. Okay, that's the basic idea. So those formulae are called compound angle formulae, and there are 4 of them. 2 for cos, 2 for sine. Among the 4, the most common one is the one which came in your investigation, one that you had in the investigation. This is the proof of that. Now the proof involves your distance formula, the cosine rule, they're all incorporated, the theorem of Pythagoras. I'm not going to go over this, right? But this is where I'm going to start from. Right, now the first one, which of the 4 compound angle identities, is the one for cos, which is, in this case, based on this page, our reference angles are beta and that one is alpha. Remember, alpha is just a value, beta is just a value. You don't have to get confused there. We can put x there and y. We can say the alpha is x, the beta is y. We can also call that alpha the capital letter A, like how I wrote here, or we can call the beta capital letter B. So sometimes in trigonometry we use the Greek letters alpha and beta. By now you should be able to know, right? Alpha and beta are the most common ones used. Now the reason why we use those Greek letters is because the foundation of trig goes a long way back, almost like over 1,000 years ago. Okay, and during that time, the Greeks were in charge of the old world. Okay? They were in charge of the old world, and their scientists and mathematicians, they are the ones who started using those letters in trigonometry. But let's not go there. Right? So you need to know that the Greek letters alpha and beta are just letters that represent values of angles. So you should not like, I saw alpha, because you saw alpha, you saw beta. Okay? Alright? You should not have like an increase in heartbeat because you saw alpha, you saw beta. There's no need for it. Okay? Now, the derivation, I'm not going to go over it, it was a bit, but I'll start from it, from the result. You can go over this as part of the investigation. So we'll start from here. Cos alpha minus beta is equal to cos alpha times cos beta plus sine alpha times sine beta. I'm just going to rewrite it here. Because very soon I'm going to do a derivation of the other 3 from it. Okay? So cosine of alpha minus beta, this is equivalent to cos alpha times cos beta. If there's a minus here, then you're going to have a plus there, sine alpha, sine beta. It's your first time, so I understand, but over time you are going to get used to it. Right? If there's a difference here for cos, then you are going to have an addition. The signs will be the opposites. So this is the derivation of this. It comes from cosine rule, distance formula. Okay? Cosine rule and distance formula, then you end up having that. So that's the first one for the compound angle formula for cos this one. Some of the questions that you were encountering in grade 10, grade 11, they can easily be done using this. Okay, usually your reduction formula from grade 11. Okay, you can use the compound angle and it will be very, very easy. Like for example, last year, remember you had something like this. I'm just going to show you this. Cos 180 degrees minus theta, right? Read this. You can use this compound angle to know the result of that. Okay? Can I show you? Then I can move on to the other two. If I follow this, it means my alpha is like the 180 degrees. My beta is like the theta. Okay? So let me use different color. So this alpha here, this is like alpha, and that will be like what? Beta. So it means when I write my next step, it will be cos 180, because that's alpha. Okay? Then this beta is equal to theta, so that will be cos theta. There is a plus here, put a plus there. That's sine alpha, which is 180. So sine 180 times sine beta, which is theta. What is cos 180? Cos 180 is equal to negative 1. Yes. So negative 1 times cos theta will give you minus what? Minus cos theta plus. What is sine 180? 1. Equal to what? You have got calculator. You have got calculator. Sine 180. Zero times sine theta. Zero. So you get this sine minus sine theta. If remember last year when you're doing the reduction formula in grade 11, you were saying cos 180 minus theta is equal to minus what? Cos theta. So here I'm showing you that using this compound formula, you can determine the answer you used to get from last year. But last year you just memorized. You didn't have a better grasp of it. So with this formula now, you can deduce it. Yes? Beta. Alright, so this is just one example. All of them, including those special angles, the co-ratios and everything, you can use this compound angle, as long as there's a difference there. But let's move on to the second one. Now, to derive the second compound formula for cos, we start with this one. Okay? So on the next page, I'm going to write this down. Right? Cos, we are going to use alpha. So cos alpha minus beta is equal to cos alpha cos beta plus sine alpha and then we have got sine beta. Okay. So I'm going to derive the other three starting from that one, using your knowledge of co-ratios and so on to carry on. So the second one, okay, I'm gonna just call it number 1. It will be cos. What is that? So this will be cos alpha plus beta. Okay, make sure you pay attention to what I'm going to be doing, because sometimes it comes in examinations. Okay? So this is the main one. I need to emphasize that. The one that I wrote there, that's the main, like the mother. Okay? Like the mother of all four. Okay? The one that you derived in the investigation, that's like the mother. And that's the one that I wrote here. This formula can be used to determine the other three. One for cos, which has got a plus, and the other 2 for sine. Okay, so this is how you do it. So I've written there cos alpha plus beta, because remember, the compound formula are trigonometric ratios that involve additions or what? Subtraction of angles. So this is the subtraction, that's the what? The addition. Okay? So on the right hand side, to carry on, you have to use your knowledge of core ratios, core functions. Okay? Remember, you said last day sine theta is equal to cos 90 minus theta. Am I right? And you said cos theta is equal to sine 90 minus theta. That was from last year. You remember that? Yes. Huh? So we are going to use that now. So I'm going to convert this and rewrite it as, make sure you look carefully, I'm going to write this cos 90 degrees minus, because this is treated as one angle, that alpha plus beta is like this theta here. So you treat the sum as one angle, so you end up with 90 minus alpha plus beta, like that. Then you have to put a square bracket there, like this. Okay? In the next step, let me use this color. The next step now, make sure you look carefully. I now need to separate this in such a way that I can create this cos alpha, the cos beta, the sine alpha, and the sine beta. To do that, I'm going to remove brackets and write it as cos 90 degrees minus alpha. Then I'll close them. Right? Then, so this is the first angle, which is like this alpha here. But there is a minus there. So to cater for that minus, right, I'm going to say minus, which is this minus here, then I'll put beta and then close the bracket. So I'll put a square bracket like that. So I have joined the alpha and the 90 degrees and separated the beta on its own so that it will look like this. I hope you can see what I'm saying. You see, I've got this alpha here. That alpha will be like this, 90 minus alpha. This minus beta is going to be the minus beta. Then, if I expand this, means where there is alpha here, I'll put 90 minus alpha. Where there is beta, I'll put beta. Where there is alpha, I'll put 90 minus alpha. Where there is beta, I'll put beta. Okay? So if I carry on here, I'll end up having cos of 90 minus alpha. Okay? In actual fact, okay? You follow me? Let's see. You might have made a mistake or something. Okay, wait. Just wait. I'll put my hands. I need to start afresh. Okay, allow me to start afresh, please. Okay, can you allow me to start afresh, please? Because I'm realizing that. Can I have your attention? Don't disrupt the lesson. Alright, I'm realizing that. Can I have your attention, please? Can I have your attention? I'm realizing that the definition that I'm trying to do here to give you the compound formula for sine, which is not what I want. So let me erase this. Just bear with me. Let me erase this. Okay, and then I'm going to redo it nicely. That's why I don't want to talk to people when I'm doing this now. Alright, so I'm going to redo it. So what I'm going to do is I'm going to start from, you see this alpha plus beta, I can write it as cos alpha minus open bracket minus beta, like that. You agree with me? Yeah. You see that they are the same. The objective of doing that is for me to end up having this alpha and that beta. So when I do that, the next thing is to say cos alpha. I'm using the right hand side now. So it will be cos alpha. This alpha here becomes that alpha. Where I put beta, I'll put minus what? Minus beta. So that becomes cos minus beta. Then I put my, now this plus here, I'm going to put it as it is for now, but it's going to change. Then where there is alpha there, I'll put sine alpha. Then where there is beta, there becomes sine minus beta. Now we are ready to go. Right? Then from there, I hope you can agree with me that this cos minus beta is equal to what? It's equal to cos beta. Okay? So you can end up having cos alpha times cos beta, right, plus, now sine alpha, I'm going to write the digit. Then I'll open the bracket, sine minus alpha, so sine minus beta is equal to what? It's minus sine alpha. Okay? Right? Then this is going to be equal to cos alpha times cos beta. This minus times this plus will give you a minus. So you end up with minus sine alpha sine beta. So this will be the second compound angle identity or compound formula. This one here. And this is for cos. Okay? This is for cosine. Right. When you write examinations, it is provided. When you write examinations, it is provided at the back in the information sheet. You know what? I wonder why you are scared of monkeys. Monkeys are scared of you. Yes. Listen. Listen. Animals are very smart. If they see that you are scared of them, then they will take advantage. So, because here in the school, most people they run away from the monkey, they know that people are scared of them. But if you show that you are brave and not scared, they won't do anything. I'm telling you. If you show that they are scared. Alright. Sorry, can I have your attention? Please do me a favor and follow what I'm doing here. We are here to do maths. We are here to do maths. Sorry?
So improving how it works.
Yes.
You don't need to know that. So you don't need to know that.
You have to know it because this can be tested in examination. Not the first one, okay? The first one, the proof is not examinable, but this one is. Can you stop that YouTube? Stop it. What I just did here is examinable. What I just did here is examinable. You know, it's very difficult to teach people this subject where you've got concentration issues. You know, your math test does not get grade 12. Your math test does not get grade 12. And I told you that. Only grade 11 trick. This is grade 12 trick. They have never done this before.
So, if you in geometry, where you get into the question.
All of red code sheet is there, red level sheet is there, sequence and series is there. It's only the graphs, yes, for tree. I send you a scope of testing. Can you please do me a favor? You need to look at it. Because I had a similar issue yesterday with the green group.
No, that's different.
Right, listen, I had a similar issue over the days when I was talking about two things: the assignment and the match control test. Some of the things they overlap. So I think during the talk, there was a misinterpretation. Plus, the other thing is there are some of you who want the teacher to tell you exactly what's in the assignment. That's not how it's supposed to be. Why?
Okay. You don't have to tell us exactly. Just have to tell us.
All right, let me carry on.
Just make what? Yes.
All right, number two. Number two, is it? All right. Now I want to do sine alpha plus beta. Okay? That's the one that I want to prove now. Sine alpha plus beta. Now this one here, I have to start from, say, cos alpha minus beta. Okay? Is going to be equal to. Now that's a class, this one here. Which means I have to take someone, I have to use what I call co-ratios I showed you earlier. So the right hand side is going to be sine, open bracket, 90 minus alpha plus beta. Okay? In actual fact, it will be alpha minus beta. Because we are using the first one to do the derivation. Okay? Alpha minus what? Beta, like this. Right? I'm going to repeat what I'm doing because some of you might say, what is he doing? I'm using this one to derive. I'm using that one to derive. As you can see, there's cos, there's alpha minus beta inside the brackets. So here, I want to prove, I want to derive the compound formula for sine alpha plus beta, but I have to start from cos alpha minus beta. So I use co-ratios here. As you can see, for me to get this plus here, it has to come from everything that I have here. So to carry on, I'll say sine, okay, it becomes sine right. Here, I have to go back a little bit. Just allow me. This is the reason why I don't want to talk with them. I end up making a list of things. So let me raise this. Sorry for that. Let me raise that. Okay, this will be equal to cos 90 minus, open bracket, cos minus 57 plus. Okay, if I use, okay, here, this is my angle, but I have to subtract it from 90, so it becomes minus alpha plus beta, like that. I'm using co-ratios, right? Then I've got a plus here. So when I remove brackets here, I need to combine the 90 and the minus alpha, but this beta is going to have to change to become a minus. So I'll write this cos 90 degrees minus alpha, okay? Then I put these two in brackets, right? Now I've got this plus here. So to create that plus, I've got this minus. Now this minus and this positive beta will create a minus beta. Okay? Will create a what? A minus beta. So I end up, if I put minus beta there, then I close the bracket. Now, what I have here is going to look like this. You see this alpha here? It's going to be that 90 minus alpha. That minus beta is going to be that minus beta. That's the objective. Okay? That's the objective. So, from there now, from here, then I can move on. I write cos, that becomes cos 90 minus alpha. Then this one becomes, now if you look at it, right, this cos beta is going to be cos beta. There is a minus here, so I'll put a plus. Then I'll write sine 90 minus alpha, then times sine beta. Okay? Then I have to simplify this now. If I simplify it, cos 90 minus alpha from the core ratios will give me sine alpha times cos beta. Okay? Now, then I'll say plus. Now, sine 90 minus alpha is going to be equal to cos alpha times sine beta. So that's the compound angle for sine, the one with the D shape. Okay? So I use the first one for cos to get it. Okay? Because I'm deeply sorry for the mistake that I made because my mind was disturbed. Okay, fortunately I saw it earlier. And I don't like to do this stuff like this when I have disturbed the things. Someone said monkeys or all this stuff. It's not supposed to be happening. I need, you see, my brain needs to concentrate on what I have here. Remember, I'm not copying from a book. Don't forget that. I'm not copying from a book. It's coming from my head, so I have to be very stable here. All right. So we are done with number 3 now. Number 3 is going to be sine alpha minus beta. Okay? Sine alpha minus what? Beta. So let me move on to the next one. So sine alpha minus beta. That's the next one. And don't forget, I'm using the first compound formula for cos. That's the one that I'm using. Okay. Okay. Thank you. So let's move on to the next page. So next page is going to be sine alpha minus beta. Now this is going to be equal to cos 90 degrees minus. Now check this, it's going to be minus, then open the bracket, alpha minus beta. Now I want you to pay attention carefully what I'm going to do here. Right. I'm going to manipulate that expression on the right. So I'll combine the 90 and alpha to get cos 90 degrees minus alpha. Okay? But for me to have this minus here between alpha and beta for sine, it means I have to put, you see, if I remove brackets here, this minus and that minus will cause the beta to become a positive what? Beta. But I don't want a positive beta, so I'll say minus, open bracket, minus beta. Like that. Then I close the bracket. I hope you saw what I did. I hope you saw. So this becomes minus beta when you close the bracket. Like that. Why did I do that? It's because this 90 minus alpha, can you look please? Can you look before you start writing? Can you stop writing for a while? That 90 minus alpha is like this alpha, right? And this minus beta is like this beta here. There is a minus here. So you can see that. That minus is going to be this one here. So I'm using the first compound formula to derive the other three. And when you are doing it, your mind must be sober when you are doing it. Okay? Then from there, I can easily carry on and say cosine of 90 degrees minus alpha, right? This is cosine of 90 degrees minus alpha. I'm now using the compound formula. That will be cosine of minus beta. Okay, there's a minus here, so I'll put a plus. So that will be sine 90 minus alpha, then sine minus beta. Okay? Can you go and get some paper after? Then I can get some paper after. Then drink some water, get some paper after. This will be equal to sine alpha.
What was that again?
Okay, this is sine minus beta. Okay? So sine alpha, this becomes sine alpha. Cos minus beta, we said it's equal to cos beta. Right? Plus sine 90 minus alpha is equal to cos alpha. Sine minus beta is going to give me minus sine beta. Now this minus sine beta is going to cause a change in sign here. When the sign changes, it becomes a negative, so you end up having sine alpha times cos beta minus cos alpha times sine beta. So that's the third one. Actually, it's the fourth one rather. But in terms of derivation, it's the third. So that's the compound angle identity. Okay? That one there. Now, I'm going to summarize all of them, all four. I'm going to summarize them. I'll start with cos, then I'll summarize with sine and so on. Okay? I'm going to summarize. So the summary is going to be like this. Make sure you pay attention. Summary of the writing heading, summary of compound angle formula. So it's going to be summary of the compound formula. Everything may be in the textbook, but you need someone to tell you how it came about. Otherwise, there was no need for teachers. Okay, so if I summarize it, I want you to be aware that it can be written as the following. You have cos alpha plus or minus beta. Since I'm combining now the two compound angle identities, of course. That's why I'm putting a plus or minus in. Right? This will be equal to cos alpha times cos beta. Now check this out. If I have a plus on top, okay, and a minus at the bottom, when I write the right hand side, the sign switch. So you end up with a plus, then a minus on top, then you have sine alpha, sine beta. Make sure you are very careful of that and that. For cos, okay? So we have got two. Then for sine, it's going to be sine alpha plus or minus beta is equal to sine alpha cos beta. Fortunately, the signs don't change. Then if I started with sine alpha, then I'm going to have cos alpha and then sine beta. Then you are done. So those are the four compound angle identities that you have to use from now on. Okay? You have to use them from now on. So we're going to do some examples so that you can know how to apply those four. Okay, but the derivation that I just did, they are examinable, except the first one, which is the main one. All right. Any question? Any question? Okay, if you don't have a question, then allow me to just go to the mind action series. Just want to do some examples, starting with that first exercise. So we're going to do step by step. Start with the easier one, then move on to the more complex and so on. So I'm going to just do some examples from mind action series. Okay, so this exercise, for this question, it says expand each of the following using the compound angle formula. Now let me write them down here. Right? We are going to be using the following: cos alpha plus minus beta is equal to cos alpha cos beta. When we say minus plus sine alpha, sine alpha sine beta. Then sine alpha plus or minus beta is equal to sine alpha cos beta plus or minus cos alpha sine beta. So I'm going to be using both. Okay? So let's start with, say, the first one. Okay? First one, 1a, you have cos x minus 40 degrees. Right? Now, here, we don't have alpha and beta, but you don't have to get confused, as I said earlier. Alpha and beta, they are just letters that represent specific numbers. So this x here, the x here is like the alpha there, and the 40 is like the beta. Okay, so you don't have to get confused. Right? So this is going to be equal to cos x, right? Cos 40 degrees, right? There is a minus here, so we'll put a plus, so that will be plus sine x sine 40 degrees. Unfortunately, 40 degrees is not a special angle, so we can't carry on. Okay? Because we are just doing an expansion. Okay, so we stop there. We're just doing an expansion. Okay? We're expanding. Right, let's try another one, like one with a special angle, like F. Okay? You want me to do C? I will do it, but let me do F first because there's got a special angle. We have got sine 45 degrees minus X. This will be equal to, now this one is sine 45 minus X, so we come here. Alpha minus beta, then we're going to put a minus. So put a minus here, minus there. Okay? And this 45 degrees, as I'm going to repeat again, is the same as the alpha. The x is like the beta. Okay? So, here you get sine 45 degrees cos x. There is a minus here, so we put a minus. Minus cos 45 degrees times sine x. Now, fortunately, that cos 45 and the sine 45, they are special angles, so I can carry on. In the first example, I cannot carry on because this 40 degrees is not a special angle. Okay? But here I can carry on because I know that sine 45 has got a specific value. And that value is going to be 1 over square root of 2. That will be cos x minus 1 over square root of 2 sine x, which I can simplify and factorize the 1 over square root of 2 and write as 1 over square root of 2 times cos x minus sine x. And then I'm done. So that's equivalent to sine 45 degrees minus x. So if there are special angles, you have no other option, you have to simplify. But if there are no special angles, you just leave it like that. Okay, so that's the expansion. Any question? Any question? Remember, I'm using the 4 compound angle formula actually. So this is the first case, right? You can do the others if you want in your own time. So let's move on to another example before the bell rings. Right. Now, question 2 is the reverse now, right? So let's do the reverse of what I just did. So now I'm going to do the reverse. We are starting from the right hand side of the compound formula towards the left hand side. So let's start with a simple one like question 2a. Now 2a, it's always wise for you to identify alpha and your beta based on that. So if I say the 3 theta is my alpha, means the theta is going to be my beta. Okay? So that 3 theta is alpha, theta is beta. You're getting that part? Then I have to relate that with those formulas. So cos 3 theta times cos theta, because there is a product here of cos, it means I must have used the reduction formula for cos. But which one now? There is a plus here. So the one with the minus. So that becomes plus sine 3 theta times sine theta. This is going to be equal to cos 3 theta minus theta, which means your final answer is going to be cos 2 theta. Okay? And then we stop there. Okay? So it's not that difficult. Right? Let's carry on and do another one for sine, like say 2c. Right? You've got sine 4p times cos 2p minus. Now I want you to be aware that this can be simplified further. But that's another topic where we are going to go. Double angles. Right? So cos 2p minus cos 4p times sine 2p. Now, since you have a product of sine and cos, it means you have to use one of the 2 compound angles for sine. But the question is which one? There's a minus here, so use the one with the minus. Right? So we write here sine. Now you have to identify your alpha and your beta. The reason why I used alpha in my derivations because your information sheet uses alpha and beta. It doesn't use x and y or a and b and b. Okay? If you look at the information sheet or NSC examination, it uses exactly the same equations that I have here. So get used to it. Get used to it. So that will be sine 4p. So 4p minus 2p. And that will give you sine 2p. Which is another double A. There. Don't worry, we'll get there. Don't worry. First you understand compound angles, then we can move on to double A's. Okay? Don't worry, we'll get more. So you see that it's not that difficult, this part. Right. Let's see if we can do another example. I can't do every question in every exercise. Right. Let's bring in more values. Now, this part that I'm going to do, it requires knowledge of your reduction formula. Okay? But the reduction formula in compound angle is good relationship. So let's start with the first one. Okay, that's fine. We can do B. There's no problem. So 3B, the question says calculate each of the following curves. Use the calculator. No calculator required. So we have cosine of 70 degrees times cos of 40 degrees plus sine 70 degrees times sine 140 degrees. Now this one is slightly more complex because you see that we've got 70 degrees here, we've got 70 degrees here. That's fine. We've got this 40 here, we've got 140. It means we have to convert this 140 to what? 40 degrees first before we start doing anything. So to do that, right, you need to know that sine 140 is the same as sine 40 degrees. Okay? You know that the sine of an acute angle is equal to the sine of 180 minus the acute angle. Okay, so from here now, we can move on and say this is equal to cos 70 times cos 40 degrees plus sine 70 degrees times sine 40 degrees. So if it was a test, you get a mark for converting the sine 140 to sine 40. Get 1 mark for that. Then let's identify our alpha and beta. Now, since we have a product for cos, we are starting with the product for cos. It makes things easy. Means this can be my alpha and that will be my beta. I have a plus here, which means my compound identity must have a minus. Okay, on the left. So this will become cos 70 degrees minus 40 degrees, which is equal to cos 30 degrees, and cos 30 degrees is a special angle. I wonder why you don't write anything down, don't talk, and don't ask questions. This will be square root of 3 over 2. And sometimes you lose concentration in the lesson. Wonder why that happens.